Okay, so what if you had a personal, always-on gatekeeper for your digital life? Someone standing guard 24/7, deciding what gets in and what stays out. Well, that gatekeeper is real. It's called a firewall. And today, we're going to break down this critical piece of tech that, let's be honest, is so often misunderstood. It really wasn't that long ago that the internet felt like this big open frontier. You could just explore, and it felt pretty safe. But that era, oh, that is a distant memory. Today's internet is way more like a digital Wild West, and believe me, there are threats around every corner. I mean, we are talking about a staggering amount of viruses, malware, and ransomware flying around the digital world every single day. And here's the really scary part. A lot of these threats don't need you to do anything. They need zero prompting, zero interaction, and they certainly don't ask for permission before they infect an unprotected computer.
Look, this isn't just about avoiding a few pop-up ads. For you and me, it's about protecting our identity, our money. For a business, it can be about survival. In the hyper-connected world we live in, having strong digital security isn't just a good idea anymore, it's an absolute non-negotiable necessity.
So, with all these dangers lurking out there, how in the world do we protect ourselves? Well, it's time to meet the hero of our story, the firewall. This is our first and probably most important line of defense against all that chaos on the open internet. So what is it, really? At its core, a firewall is basically a relentless filter. I want you to think of it like an incredibly vigilant bouncer at the hottest club in town, or maybe a seasoned traffic cop at the busiest intersection you can imagine. Its one and only job is to inspect every single piece of data trying to get into or out of your network, and just block anything that looks suspicious or isn't on the guest list. Okay, so how does this digital gatekeeper actually make those decisions? How does it decide who gets the VIP pass and who gets bounced? To really get it, we need to learn the language it speaks, which is the language of the web itself. First up, packets. See, nothing on the internet travels as one giant file. That's just not how it works. Instead, every single email, every video, every web page you look at is broken down into these small, manageable little digital envelopes. Each one carries just a tiny piece of the bigger picture, and they're all designed to be put back together perfectly at their destination. Now, for these billions of packets to actually find their way, they need an address. And that's exactly what an IP address is, a unique number for every single device online. Just like a physical letter needs a street address to get to the right house, every single packet needs an IP address so it knows exactly where in the world it's supposed to go. But here's the thing. Just getting to the right street address isn't quite enough. Right now on your computer, you're probably running a browser, maybe a music app, your email, all at the same time. This is where ports come in. If the IP address is the big apartment building, the port is the specific apartment number. It tells that digital packet exactly which application gets the delivery. And you can bet your firewall is paying very close attention to all three: the packet itself, its destination IP address, and its target port. Now, the internet doesn't just randomly chuck all these packets around hoping for the best. Nope. It uses specific sets of rules or protocols to send them. And two of the most important ones, the ones firewalls care a lot about, are called TCP and UDP. So what's the difference? Well, it really just comes down to style. Think of TCP like a premium white-glove courier service. It establishes a secure connection, it makes sure every single packet arrives in the right order, and it even requires a signature. It's super reliable, but it's a bit slower. UDP, on the other hand, is like shouting a message across a really crowded room. It's incredibly fast, but there's just no guarantee that every single word is going to be heard. So how does a firewall use all this info to make a split-second decision? It follows a really strict sequential rulebook. When a packet shows up, the firewall starts at rule number 1 and asks, does this match? If it does, boom, it takes the action, either allow or deny. And this is the critical part. It stops right there. It doesn't check any more rules. So yeah, the order of your rules, it's everything. And this all leads us to the single most important principle in all of firewall security: default deny. It's a simple idea, but it is so powerful. It means that unless a rule explicitly allows traffic to pass, it is automatically and without question blocked. See, instead of trying to make a list of everything bad out there, which is impossible, you only permit what you know for a fact is good.
Of course, just like pretty much any other technology, firewalls haven't just been standing still. They have evolved dramatically over the years, going from really simple gatekeepers to highly intelligent security systems.
The very first firewalls were what we call stateless. Basically, they had no memory. They looked at every single packet in total isolation. Then came this huge leap to stateful inspection. Now the firewall actually keeps a record of active connections. It's like a guard who remembers who just left the building and will only let those specific people back in. And today, the most advanced ones are application layer firewalls, which can literally open up a packet and inspect its contents to see if there's a threat hidden inside.
In that 2004 milestone you see on the timeline, that really shows the real-world impact of all this. Can you believe it? Microsoft initially shipped Windows XP with its firewall turned off by default. They were afraid it would break people's internet apps. It took years, and I mean countless infections, before Service Pack 2 finally flipped that switch to on by default, which really signaled how hostile the internet had become.
It's also worth knowing that firewalls come in two main flavors. You've got hardware firewalls, like the one built into your home router, that protect your entire network. And then you have software firewalls, which run on a single computer, kind of like a personal bodyguard for just that one device. The best practice? Use both. It's a critical security strategy we call defense in depth, where you have multiple layers all working together to protect you.
Now, it is really tempting to think of a firewall as this magic bullet that's just going to solve all of our security problems. But to be truly safe, it is absolutely crucial that we understand what a firewall can't do. A firewall can't do anything about a threat that's already inside your network. It can't protect you from an authorized user who decides to do something malicious. But most importantly, it cannot stop you from being tricked. A firewall has no way of preventing you from clicking a malicious link in a phishing email or voluntarily giving away your password, because at the end of the day, it's just code. It doesn't understand human psychology.
And this is precisely where this concept of the human firewall comes into play. It's this powerful recognition that technology by itself is never enough. Your own vigilance, your awareness, your critical thinking, that is an essential and often the final, irreplaceable layer of your digital defense.
And to make sure your technology is actually effective, you have to avoid these common mistakes. Leaving too many ports open? That's just like leaving a bunch of windows unlocked all around your house. Using what's called an any rule? That's like telling the bouncer at the club to let absolutely everyone in, no questions asked. And failing to change default passwords? Well, that's just leaving the key right under the doormat. Ultimately, a set-it-and-forget-it mentality is a recipe for disaster. Look, a firewall is an incredibly powerful tool, no doubt about it, but its true effectiveness really comes down to how carefully you configure it and your ongoing active vigilance.
So here's what it all boils down to. We can build these powerful digital walls with amazing technology like firewalls, but in the end, security is a partnership between the machine and the user. And the real question you have to ask yourself is this: are you the one strengthening that defense, or are you unintentionally the weakest link?